So now the question is, this is very basic. Amino acids are the building blocks of. So for this week content, there were not much questions which were directly related. So I've just taken the sample problems which could be helpful. Blocks of carbohydrates, vitamins, fats, and proteins. Okay.
Proteins.
Yes, right, exactly. So the next is the functional group which is found in amino acid is carboxylic acid, amine, CH3, and the D answer is both A and B. So this is,
Both A and B.
yeah, both carboxylic acid and amino group. So these were the questions I had. Now, like, we have almost half an hour left. If you have any questions, you can ask me. I could collect only this much content for this week.
Mm, Ma'am, I have questions about improper axis of rotations.
You have question on improper axis of rotation. Okay,
Mm,
fine. Let us try. So yeah, tell me what do you want to ask?
Ma'am, for BF3 molecule, how to tell how many improper axes are there?
Okay. So BF3 has a trigonal planar structure. It has C3 axis as the principal axis of rotation, which is perpendicular to the plane of the board. Then sigma h horizontal plane. So in this molecule, we will have two C3 axes, C31 and C32. That is 120-degree and 240-degree rotation, which will give us an equivalent configuration. We also have identity operation. Then C2 C3 axis, which is C31 and C32. We will have horizontal plane, three vertical planes, and now the number of S3, that is, we will have S3 improper axis of rotation. So now we will have two S3 axis of rotation, that is S31, S32, and then S33 is basically identity operation only. So this we don't have to consider, this is only identity operation. So we have these two improper axis of rotation, because we have, if we rotate this molecule at 120-degree angle, that is clockwise, we will get F1, F2, F3, BF3, F1, F2. Now if you rotate this molecule again at 120-degree angle, what will you get? BF2, F1, F3. We'll get F2, F3, and F1. So these are the equivalent configurations you will get after two C3 axis of rotation, that is C31 and C32. Now we have the horizontal plane perpendicular to these axis of rotation. So corresponding to that, we will have two improper axis of rotation, that is S31 and S32. So S31 is basically C31. We will have to rotate the molecule at this C3 axis of rotation, and then we will have to reflect the molecule perpendicular to the plane perpendicular to it. Similarly, we will have C32 and then sigma h. So based on these two axes of rotation, we will have two improper axes of rotation in this BF3 molecule. uh, आपको समझ आया?
Yes, ma'am.
Okay, I'm not sure. Like, I'm trying to explain it uh, possibly, but I might not be good at teaching. But I hope you get it, or you can tell me. I'll try to explain it in a better way.
Ma'am, um, when we do for horizontal plane, when we pass for S3 one axis,
Hmm.
we will get the improper axis of rotation.
Yes.
But for S32, if we write means we will get C32 cross sigma h square.
No.
Hmm.
Okay. 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 Yeah. Yeah. You are saying. Okay. Sigma s square.
Now sigma h square is equal to identity, so
Yes.
that we will end up with the C32.
Yes.
Hmm. So um,
We will have only one improper axis of rotation that way.
Eh, yes, ma'am. This question is discussed in day one discussion class, but my doubt is why sigma h plane is taken as it is, but why sigma h square plane is taken as identity.
Okay.
After that, S33 axis is done, where sigma h thrice is given as formula. That time sigma h plane is taken counted, not as identity.
Okay.
So how these planes are counted? That's confused.
Hmm. Okay. Right. Right. You are right. On you have a good question. So, for example, we have C31, C32, and C33. This is identity operation. So, because 120 degree plus 120 degree, then plus 120 degree, you will get 360 degree. So, this is identity operation again, right? But these are 120 degree and 240 degree rotations, which are different to each other. So we will have two proper axis of rotation. Now coming on improper axis of rotation, S31, S32, and S33. So basically S31 is C31 into sigma h1. This is C32 into sigma h square. This is C33 into sigma h cube. So here we have B F F1, F2, F3. So you will apply the C31 operation. We are moving clockwise. Okay. So here we will get F3, then F1, and F2. Now, the plane perpendicular to C3 is the molecular plane, which is the plane of the board. So, you will get the equivalent configuration. You can't differentiate between the fluorine atoms. So, whether it is fluorine 1, 2, or 3, it is going to be an equivalent configuration. So, it is clear that we have this S31 is present in the molecule. Now, if we go on the S32, S3 2 is C3 square into sigma h square. So even power of sigma h square gives you identity operation. That is, if you are, for example, you have this A and you are reflecting it. Okay, let's say it this side is uh, I'm representing it like this side is dotted and you are reflecting it. So on first reflection, that is sigma h1, you will get this configuration, right? On the next reflection, you will get the same configuration, right? Are you getting me?
Yes, ma'am.
That is, the even powers of horizontal plane gives you identity operation. That is, sigma s square is E, sigma h4 is E. That is, no reflection is being introduced, we can say. But that's why here you will get C3 2 into identity operation, and therefore as a result you will have only C32 axis of rotation, which we have already counted. So this won't be counted again. S32 is not an improper axis of rotation that we have to count again, because it is equivalent to C32. Now this is S33. We have C33 axis of rotation and then sigma h cube. So C33 is basically identity operation now. Got it? And this sigma h3 we can
Yes,
represent
ma'am.
as sigma h square into sigma h, right? So this sigma h square is identity operation. We get is only horizontal plane as a result.
Okay,
And
ma'am.
then if we count sigma h, which we have already counted in the number of symmetry elements, we can't count it again. So S33 is equivalent to sigma h. So the number of improper axis of rotation here we get is 1, which is only S3 1.
Okay, ma'am.
Okay, so you were right here that S33 is equivalent to sigma h, S32 is equivalent to C32, and we have this S31 improper axis of rotation. So you have to write all the possible. For example, if you are saying that you have an S6 improper axis of rotation, then you will have to write S61, S62, S63, S64, S65, S66. So this will be present C62 into sigma h square. This will be equal to identity operation, and this will be equal to C31. If you in this molecule you already have C31, then you can't count it again. So you will not have this S62. Okay. Similarly, for this S63, you will write C63 into sigma h cube. This is equivalent to C2 axis of rotation, and this is equivalent to sigma h. So that you can count here. So this is how you will find out the number of improper axis of rotation. The even power of sigma h will become E. Is it helpful? Clear to you?
Yes, ma'am. Clear.
Okay. Any other question? C32 into sigma H4 is equal to C32 C65 into sigma H5. We will find it out as C65 into sigma H. Then C66 is equal to identity operation into sigma H raised to 6. So overall S6 is equivalent to identity operation.
Ma'am,
Yes,
for assuming point group of staggered form of methane,
yes,
staggered and gauge form of methane,
staggered
and a gauge form of ethane molecules.
ethane, staggered and eclipsed form of.
Staggered and a gauge form.
Can you write in the chat box the second
Ah, okay,
one?
ma'am.
Hmm. Staggered and gauche form of ethane. So if I represent it as a in a Newman projection, CS3, CS3, H, H, H. This is staggered form and so the gauche form will be H, H and H. This is eclipsed form, this is gauche form. So now you have to find out the point groups in these. So here we have C3 axis of rotation, which is coming like out of the plane of the board. Okay, and then we have sigma v planes, which is passing through each ch bond. These are the sigma v planes present in this. Okay, we have e c3 3 sigma v, and we don't have this horizontal plane, because if you the horizontal plane in this case will be the plane of the board, that is molecular plane. So behind this hydrogen, if you reflect the molecule, you won't get a hydrogen behind it. Okay, this is possible in the eclipsed form. So there you can say you have C3H point group. In fact, so here we have 3 sigma 2 also. So we have C2 axis of rotations, 3 C2 are present. So here we have D3D point group in this molecule. But in the gauche form, we have only C2 axis of symmetry. Which is passing through these bonds, C2 axis of symmetries. So here we have also sigma V planes on these C2 axis of symmetry. So in this case, we will have C2V point group, and in the eclipsed form, we will have D3H point group. So these are the difference between these three geometries of three isomers of ethane.
Noted, ma'am.
Yes.
Yes, ma'am, I have noted down.
Sorry, your voice is not very clear. I'm not getting. What are you saying? Okay, noted. Okay, fine. So in the staggered form D3D point group, gauche plane we have C2V point group, and then eclipsed we have D3H point group. Okay, any other question? Okay, great. So any suggestions you want to give, Anita? Any like change in content or any improvement I can, because I'm also teaching for the very first time in these lectures, so it would be helpful. Your feedback will be appreciated. So since these are interactive sessions and you are the only student, I am requesting other students to also join. This way, it will be helpful for me also uh, to interact and the content you want to discuss, any doubts you have, or whatever you want to discuss in these sessions. Okay. Thank you so much, Anita, for your feedback. So I'll be waiting for 10 more minutes if someone join in between and has someone any doubts. Okay, welcome Anita, and thank you so much for this engaging interactive session. Your attention was very helpful. Okay, Anita, you can leave. And I'm looking again on this ghost question. And if I have some clarification, I'll record and you can watch it in the recorded video. Okay, thank you so much. Ghost form of ethane. So we have C3 axis of rotation again present in this molecule, which I'm like repeating this answer again. So after C3 axis of rotation, we will get an equivalent configuration, so yes, we have C3 axis of rotation present in this molecule. Then we will find out whether we have 3C2 perpendicular to this C3 axis of rotation. So if you, let's say this is C3 axis of rotation which is coming out of the plane of the board in the through the center of the molecule, and if we see, let's say this is the C2 axis present in the molecule. Let's suppose, and if you apply this C2 axis of rotation, you will get H1 S3 here, S2 as it is. Similarly, H5 will remain as it is here. But this H4 will come like this. So these are not equivalent configurations. So C2 axis of rotation is not present because this hydrogen atom was present ahead of this hydrogen atom, but here this is coming behind the this H1 atom. So now C2 axis of rotation is not present in the molecule. Then we have to find the sigma H plane is present or not. So perpendicular to this, if we bisect the molecule that is in the molecular plane of the board, then we won't get an equivalent configuration. We will we will get the configurations like this. H1, H5, S3. So we will get H4, H5. So sigma H is not present. Then we will see whether N sigma D is present or not. So basically, due to different angles, that is, gauche is in between like 60-degree angles between these hydrogen atoms, which are like H2 and H5 are at 60-degree angle with respect to each other. So there is a difference that we apply horizontal and vertical planes in them, and we are not going to get the equivalent configuration. So the gauche form has D3 point group present in it. Okay, so thank you. This was all for today's lecture. Hope some other students also join in the upcoming sessions. Okay, so I am ending today's sessions. Thank you so much.